Hi, this is Jonathon Goodson. The purpose of this video is to showcase some of the features of my term project for the course Computer Science 6119. I chose to develop an application pertaining to the stock market. The comprehensive details of my project can be found in this project document that I've submitted, but I am happy to give a quick tour right now. As I said, it has to do with working with investing in the stock market, the users and stakeholders of this application, anyone who is interested in stock market speculation, including people that have jobs like these, fund managers and day traders. With regards to the scope of the application, there are two main features of what it was built to accomplish um, with regards to speculation and notification. As far as speculation, you just think of this as if you invest so many dollars into something, what is it worth, or if you had in the past, what is it worth today? Or if you invest today and check back later, what is it worth now? Um, and in the demonstration, it will be demonstrated what the workflow of this feature is like. Also, the notification there's very much a valid usage scenario where, say, you want to you have bought a particular stock and it has gone up in value, and if it goes up to a certain threshold, you might very well be inclined to sell that stock for a profit. The fundamental purpose of having developed this application in this class is to implement a number of well-established design patterns, and throughout the demonstration we'll talk about the ones that I've used, and a very brief usage description. This is how you run the program. You start it up. There's one main method in this class called runme.java, and the first thing the program will do is prompt you for a username, and after that point it will present you with the REPL, a read eval print loop. It will present the user with a menu of commands. The user will enter a command, and the application will prompt that user for various input values depending on the choice that he or she selected. Here's the class diagram for the project. The main classes are user and especially portfolio. Portfolio consists of a number of stock purchases here, and stock purchases consist of a single stock. A couple of things to take note of are this observer and subject interface. These have to do with the observer pattern that was implemented in this project. So here is the code of the application. Before we actually run through the demonstration, let's take a quick tour of the classes. This is the stock data class. This is the class that returns stock prices, and unfortunately I rigged it up in a way that it actually does not return actual stock prices. I've just merely rigged up some fake stock prices. The reason I did this was because at the outset of this project, I thought that I would be able to leverage a free API to get stock price data, but it seems since the last time I leveraged Yahoo's Finance API, they've either deprecated it or discontinued it. So I was not able to actually retrieve real-time data. This isn't too big of a deal for this project because we're really just experimenting with the concepts here. Stock, as you see, is a very minimalist class that only consists of one attribute and a constructor that sets the attribute. User, there's a one-to-one relationship between portfolio and user. It also has the attribute name, which is a string, and it also implements the observer pattern, which we will get into what that means for the user during the demonstration. Getters retrieve attribute values for the user. It has a constructor, and this update has to do with the observer pattern, which we'll get into. Portfolio is definitely a class of significant consequence in this application. Its attributes are an array list of stock purchases, and it provides a utility for showing the summary of a user's portfolio. It also provides for adding a stock purchase for the portfolio, and this check for stock changes is an interesting thing. It is what is going to be leveraged for the observer pattern, which we will showcase in the demo. So let's run the demo. Once I run it, this is what I am prompted with. It's a stock market app. Enter a username. I will enter my name, Jonathan. And then I am presented with a number of options I can select. 0 will exit the program. User option 1, that's where I can print all of the stocks that are available to the user to make a purchase. U2 is where I can make a stock purchase. And U3, user option 3, is where I can print the current status of my portfolio. This admin options, option A1, change stock price, obviously. If you had an app, you would not want to allow a user to change the stock price. The reason I have this, as I mentioned earlier, I was unable to find a finance API I could leverage, at least for free. So in order to simulate what it would entail if a stock price were to change, I implemented this administrative utility for demonstrative purposes, where I am able to change the price of a stock to showcase the features of this application. Let's begin by printing the available stocks. So by entering U1 and pressing enter, I can see that Coke trades for 40, Apple for 45, Delta 50, Home Depot 55, and so on. Microsoft trades for 60. As I mentioned in the beginning, the design of this command line application is a REPL loop where it just reads in the value you put it evaluates it, it prints or acts or does something, and then it does it all over again. So here we are back at the user options, which we saw the same thing a moment ago before the last time we chose an option. So let's now print the current value or the current status of our portfolio, option 3. And it'll tell you, well, you haven't made any purchases yet, which makes sense because we haven't. So let's go ahead and do that. Let's select user option 2, U2. Let's enter a ticker symbol, which is one of these. Let's start off by buying Coke, KO. Let's just buy 100 shares to make the math easy. And then let's select user option 3 to select the current status of our portfolio. And it says purchases made. Coke, we bought 100 shares. We purchased it at 40. It's currently at 40 because the stock hasn't changed. So we have profited nothing on this particular purchase, but we haven't lost anything on this purchase either. The total value of our portfolio is $4,000, $40 at or 100 shares at $40 a share. That's $4,000. And as we mentioned a moment ago, the price of our stock has not changed yet, so we have neither profited nor lost any money. Let's buy a couple of more stocks for our portfolio. First, let's enter user option 1 just to see what's available to us. We will now buy some Apple. So user option 2, enter our ticker symbol AAPL. In our quantity, let's just do 100 again. Let's also purchase some Delta, DELT. And now let's examine the current status of our portfolio by selecting user option 3. The purchases we made are the 3 we have just made. We purchased 100 Cokes, 100 Apples, and 100 deltas, and they were trading at 40, 45, and 50 respectively. They are currently still trading at those amounts because in our application, no stock prices have changed yet. All that adds up to 13.5, and as we mentioned, no stocks have changed price yet, so we have neither profited nor lost any money. All right, let's now showcase the administrative utility where we change a stock price. First, let me see the stocks that are available for us to purchase by selecting user option 1. I'm going to change Microsoft. Right now it's trading for 60. We're gonna change that. So I'll enter administrative option 1, A1, enter the ticker symbol. Microsoft is MSFT. Its new price is 61, so it went up $1. And I will again display the available stocks to purchase by selecting user option 1. And we see now where it was once 60 is now 61, just to demonstrate that this works. Now let me actually do something a little different. Let me change the stock price of a stock that is currently in our portfolio. And just as a reminder, I'll select user option 3 to display the current contents of our portfolio. And we see that we have Coke, Apple, and Delta. So let's change the price of Delta to showcase something. I'll select administrative option 1, DELT. It was trading at 50. Let's say it went up $1, so now it's trading at 51. And here's what I wanted to showcase, this alert. The reason for this alert is when a user is created, he is automatically registered to receive notifications about stock price changes for stocks that belong in his or her portfolio. This is done by leveraging a programming pattern called the observer pattern. In this application, the stock data is the subject of the observer pattern, and the user is the observer. The way that this works is when this update price method is called, it leverages this notify observers method, which leverages this for observers, and observers, as I mentioned, when a user is created, they're kind of involuntarily subscribed to receive notifications. So it goes to update here. User hands this off to the portfolio method check for stock changes, which is right here, and it has passed that last stock that was updated in the new price, and basically it goes through the purchases that already exist inside the portfolio. This line here basically says, is this new stock part of the portfolio? Because we just don't really care about stock changes for stocks that we haven't purchased yet. And that's what we saw earlier when we changed Microsoft to 61. Notice when we did that, we did not get an alert. However, when we changed the price of Delta to 51, we were alerted because we did in fact own Delta stock. Another programming pattern that we used in our application is this thing called a singleton, and then we leverage it right here for this stock data object. So as we mentioned at the beginning of this demonstration, stock data is the object that actually gets stock price, and it doesn't make sense for more than one of these things to ever exist. I mean, it's just an object that gets the price. There's just no point in ever having more than one of them. So we don't actually ever create that object whenever we need to reference a stock data instance to get price or something. We call it this way, stock data, and we leverage the .get instance method of it. When we call that, what it does is lazily instantiate something. If it's been called for the first time, it actually instantiates it privately. This is a private constructor, and then it returns that one instantiation, and it only ever returns that first instantiation of stock data. That pretty well covers all the features of the application except this last one, 0 to exit, and I'll prove that works. 0 and build successful, which pretty much means we're done. Without any more features, that pretty much wraps up our demo of our project. Thanks for watching.